All right, so imagine you're, building something really complex,
Huh?
like a car.
Yeah.
You wouldn't just scatter all the pieces on the floor and hope they just, magically assemble themselves.
Right, right.
You'd need a plan, right? A blueprint.
Absolutely. A set of instructions, something to guide the process.
Exactly.
Yeah.
And it's kind of the same when we're talking about, building automated tests for software.
Mm-hmm.
As things grow and get more complex without some structure,
Yeah.
your test scripts, they can become, well, a bit of a mess.
A chaotic mess, a real tangled web.
Exactly. And that's where these things called design patterns come in.
Yeah, design patterns are essential.
They're like those blueprints we were talking about.
Mm-hmm.
But for your code,
That's a great way to put it.
they provide a way to, organize your tests
Yeah,
to make them reusable so you're not constantly writing the same logic over and over again.
exactly. And that's a huge time saver.
And they make your code so much easier to maintain,
Right, because the application you're testing is always evolving.
always changing. Yeah.
Yeah.
And with these design patterns,
Yeah.
you can adapt your tests without having to, rebuild everything from scratch.
Precisely, it's about making your automation efforts scalable.
Scalable, that's the key word.
As your application grows, your tests can grow with it.
So for this deep dive, we're going to explore some of these essential design patterns
That's right.
that can help you write better automation code.
Without getting bogged down in unnecessary complexity.
Exactly.
Yeah, because it's not just about writing more code.
Right.
It's about writing smarter code.
Smarter, more efficient,
Exactly. Code that is designed to be modified in the future.
and code that facilitates collaboration.
Absolutely, because these patterns, they provide a shared vocabulary.
Yeah, that's a good
For
point.
your team, everyone's on the same page.
So let's start with something really fundamental.
Okay.
How we manage our, browser instances during testing.
Yeah, that's a good place to start.
So think about it. Every time a test needs to interact with a web page, it has to fire up a new browser.
Right.
It's like needing a whole fleet of cars just to test different parts of one car.
Yeah, that's a good analogy.
Not very efficient, is it?
No, not at all.
And that's exactly the problem that the singleton pattern solves.
The singleton pattern.
Yeah, it ensures that only one browser, or more accurately, one WebDriver instance.
Right. The WebDriver is the control center for the browser.
Exactly, is active throughout the entire testing process.
Which is so much more efficient.
Way more efficient, yeah.
And what's really clever about the singleton pattern is that it acts like a gatekeeper.
Okay.
It makes sure that only one WebDriver instance is created.
How does it do that?
Well, it checks to see if an instance already exists.
Oh, okay.
And if it does, it just provides that existing instance.
And if it doesn't?
If it doesn't, it creates one.
Oh, I see.
And then it remembers that instance for all future requests.
So, you only need one key to start the car.
Exactly. Just one key for all the tests.
So how does this look in the actual code?
Yeah, well, the source material provides a really good example. There's a class called WebDriver Manager,
WebDriver Manager.
and it holds a single instance of WebDriver.
Okay.
And then there's this method called getInstance.
Right.
And this method is responsible for checking if that WebDriver instance already exists.
Gotcha.
If it doesn't, it sets up Chrome Driver and creates a new Chrome Driver instance.
And if it does exist...
If it does, it just returns that existing instance.
Very clever.
Right. And to prevent any accidental creation of new WebDriver Manager objects from other parts of the code, the constructor of this class is private.
Oh, so it's like a locked door.
Exactly. You can't just barge in. You have to use the designated entrance.
So the getInstance method.
Yes, that's the key.
So what does this mean for someone writing tests?
So in your test code, instead of creating a new Chrome driver directly,
Right.
you would call this WebDriverManager.getInstance method. And every time you call this method within your test suite, you're guaranteed to receive the same WebDriver instance.
That's pretty cool.
It's a really powerful way to manage your browser instances.
So the singleton pattern essentially helps us avoid having a bunch of unused browsers open.
Absolutely. It keeps things clean and efficient.
And that speeds up our tests.
And saves valuable resources.
It's a win-win.
Exactly.
So let's move on to the next pattern
Okay.
and talk about how to keep our test code itself organized,
Right.
especially when we're dealing with web pages.
Web pages are constantly changing.
They're always evolving, and if our methods for finding elements on those pages,
Those locators.
those locators, things like by.id or by.xpath.
Yeah, it's like the address of an element on the page.
Exactly. If those are scattered all over our test scripts, updating them can be a real pain.
It can be a nightmare. Imagine having to find and change the same instruction in dozens of different
It's
documents.
like trying to find a needle in a haystack. But thankfully, there's a design pattern for that, too.
The page object model.
The page object model, or POM for short.
POM.
POM comes to the rescue.
Yes, it does.
It's all about creating these dedicated classes
Mm-hmm.
that represent the different pages of your application.
So for every page on your website, you would have a corresponding page class?
Right, and within these page classes, you define all the UI elements.
Those locators we were talking about.
Yeah, and the actions you can perform on them.
Like clicking a button or entering text into a field.
Exactly. So let's say you have a login page.
Hmm.
You would have a login page class.
Right.
And in that class, you define locators for the username field,
The password field.
the login button.
And you would also have methods
Yeah.
to interact with those elements.
So a method to enter the username
A method to enter the password.
and a method to click that login button.
Exactly.
Now, our source material gives us a nice example of this login page class.
Let's take a look.
You can see it has a WebDriver instance.
Yeah, which is specific to this page.
Right. And then it defines those locators using things like by.id.
Okay.
And it has those methods we talked about, enter username, enter password, and click login.
And those methods use the defined locators to actually interact with the elements on the page.
It's all very neatly organized.
It is, the beauty of POM is in its organization.
And what's really cool is that it abstracts away the complexity.
Yes, your test code doesn't need to worry about how to find the username field.
Right.
It just tells the login page object to enter the username.
And the login page class handles all the behind-the-scenes stuff.
Exactly. It's a much cleaner approach.
So how would we actually use this in our tests?
So in your test script, instead of directly finding elements and interacting with them, you would create an instance of your login page class,
Okay.
and you would provide it with the active WebDriver instance,
And then
you would simply use the methods provided by the login page object.
so instead of writing all that code to find the elements and interact with them,
You just say something like login.enter username,
user 123.
and then login.click login.
Exactly. It's so much more readable.
And here's the best part.
What's that?
Let's say the ID of that login button changes on the website.
Oh, yeah. That happens all the time.
It does. With POM, you only need to update that ID in one place, in the login page class. Exactly. All your test scripts that use the click login method will automatically use the updated ID.
That's a massive time saver.
Huge time saver. No more searching through tons of files.
And it makes your automation code so much more resilient to changes.
Much less fragile.
Yeah.
Exactly.
So POM is all about organization and maintainability.
It's a game changer for sure.
Okay, so now let's say you want to run your tests on different browsers.
Cross-browser testing.
Yeah, you want to make sure your application works not just in Chrome.
But also in Firefox and Edge and maybe even Safari.
Right, but if you're hard coding the browser setup in your tests,
Yeah.
you need to create separate versions of your code for each browser.
Like having to build a different car for each type of road?
That's not very practical.
No, not at all.
Luckily, there's a design pattern for this too.
The factory pattern.
The factory pattern.
Yeah, it's like having a factory that produces different types of cars
I like that analogy.
based on your specifications.
So instead of directly creating a Chrome driver or a Firefox driver, you ask this factory to give you the right driver.
Based on the browser you want to use.
Exactly.
So the source material shows us a basic example of this
Okay.
with a class called choose_browser_type.
Choose browser type.
And it has this method getDriver
Right.
that takes a string as an input,
And that string specifies the browser type.
exactly like Chrome or Firefox,
And then inside the method, it uses a switch statement.
to determine which driver to create.
So if you pass in Chrome,
It sets up Chrome driver and returns a Chrome driver object.
and if you pass in Firefox,
It does the same for Firefox.
makes sense.
Right.
Mhm.
And if you try to use a browser that's not supported, it throws an error.
So how would we use this in our test code?
So instead of using something like new Chrome driver, you would use driverfactory.getDriver.
Driverfactory.getDriverChrome.
And if you want to switch to Firefox,
Yeah.
you just change that string to Firefox.
That's so much easier than having to rewrite a bunch of code.
It's a very elegant solution.
So the factory pattern makes cross-browser testing a breeze.
Absolutely.
And the source mentions that this is just a basic example.
Right. There are more advanced implementations out there.
So there's always more to learn.
Always.
Okay, so let's talk about our final design pattern for today.
Okay.
And this one's all about making our test steps easier to read.
Readability is crucial.
It is, because sometimes even with well-structured page objects,
Yeah.
our test methods can still look a bit cluttered,
They can be hard to follow.
like a long list of instructions.
Exactly.
So let's imagine a test for logging into an application.
Okay.
You might have separate lines of code for entering the username,
Entering the password?
clicking the login button.
Right.
It works, but it's not the most elegant solution.
No.
The Fluent interface pattern provides a way to make this flow much smoother.
The Fluent interface pattern.
Yeah, it's all about method chaining,
Method chain.
where each method returns the object itself.
So you can chain multiple method calls together.
Exactly. It's like writing a sentence,
Oh, I see.
where each word builds upon the previous one.
That's a great analogy.
And our source material shows us how to do this with our trusty login page class.
Okay.
The enter username and a password and click login methods.
Yeah.
They've been modified to return this.
Which refers to the current instance of the login page class.
Right, so now we can chain those method calls together.
Like this new login page driver dot enter username, user123 dot enter password, password123 dot click login.
It reads almost like a natural sentence.
It does. It's so much easier to understand what's happening.
It's beautiful code.
It's elegant and expressive.
So the Fluent interface pattern makes our tests much more readable.
And therefore much easier to maintain.
And less intimidating to look at.
Absolutely.
So let's recap what we've learned.
Okay.
We've covered 4 fundamental design patterns for automation.
The singleton pattern,
The page object model,
the factory pattern,
and the Fluent interface pattern.
each of them addresses a common challenge in automation.
And they all work together to create more robust and maintainable code.
And scalable code.
Right, scalable code.
And these patterns aren't just for experts.
Anyone can use them.
They provide a structured approach to writing automation code.
That can save you a lot of headaches down the road.
Headaches and time and effort.
Exactly.
It's all about working smarter, not harder.
So happy coding, everyone.
Happy coding.
And as a final thought, we'd like to leave you with this.
Okay.
Think about how you can apply these principles of structure and organization, not just in your test automation.
But in any complex task or project you're working on,
Whether it's writing code
or planning an event,
or even just organizing your closet.
the principles are the same.
Have a clear plan
Separate responsibilities
and make sure your work is understandable.
by you and by others.
And that's our deep dive for today.
Thanks for joining us.
We'll see you next time.
Bye for now.